What if I told you that with just a couple of simple components, a light, a button, and a tiny little computer, we could actually build something that seems really complex, like a smart alarm system? Well, today, that's exactly what we're going to do. We're going on that journey, from a single spark of an idea to a system that can actually react to the world around it.
It really all starts with this massive question, right? How do you build a machine that thinks? Or, at the very least, one that can make decisions all on its own? It might feel a little bit like magic, but I promise you, it's not. It's just logic, broken down into simple, easy-to-handle steps.
I mean, just take a look at this thing. This is the finished circuit. With all its lights and the sensor and the buzzer, yeah, it looks pretty complicated. But the entire journey to build this system, it starts with just one single component, a light bulb.
So to get from that one light to the final alarm, we need a way to connect our ideas to the physical world. And for that, we'll be using this little blue board, an Arduino. Think of it as our digital brain. And how do we give it instructions? Well, through code. Honestly, it's just like writing a recipe for electricity to follow.
So our mission is clear. We're going to build a simple alarm system. And the way we'll do it is by breaking the whole problem down into these small, manageable pieces, building up our logic one layer at a time. All right, let's dive in.
Okay, step one, the simple switch. Before our system can do anything fancy, we have to teach our digital brain the most basic command in the entire universe, how to turn a light on and how to turn it off.
And here it is, our very first setup. It is as simple as it gets. We have an input, that's this green button. We have an output, the green light. And connecting them both is our brain, the Arduino. The rule we're going to write is super simple. When you press the button, the light changes its state.
Now, this brings us to a really crucial idea, state. I mean, how does the brain even remember if the light is already on or off? Well, it uses a tiny piece of digital memory, a variable we're calling LED state. So every time we press that button, the code just flips that little piece of memory from on to off, or from off back to on. This is the circuit's very first memory.
Okay, so now that we have some basic control, what if we want the system to do something on its own, without us having to press a button every time? This is where we teach it to follow a pre-programmed sequence.
See what's different here? The button is gone. And we've also added a red light. That's because we don't want to give the brain direct commands anymore. Instead, we want to give it a whole routine to follow automatically. Something like, stay green for a few seconds, then flash the red light. So, how do we get it to repeat something like that? We use something called a for loop. This single line of code is basically just an instruction that says, hey brain, whatever is inside this next block of code, I want you to do it exactly 4 times. It's how we create patterns and automated actions.
Now this next step is really fascinating because we're going to change the purpose of a component. We're bringing our button back into the mix, but it's not a command button anymore. This time, it's a sensor. We're literally giving our system a way to feel or detect what's happening in its environment.
Just look at these two circuits side by side. The physical hardware, it's almost identical, but the logic behind it is completely different. On the left, pressing the button is a command, change the light. But on the right, the button's status is now a question, is there an error?
We've just taught our system how to make a decision. The code is now constantly asking, what is the sensor telling me? If the sensor state is high, which for our circuit means everything's connected and good to go, then the green light stays on. But if that state goes low, meaning the connection's broken, an error has been detected. The system now reacts by turning on the red light. See? It's not just following orders anymore, it's reacting to its environment. So at this point, we've actually built all the individual pieces we need. We've got an output light, we know how to create automated sequences, and we have a sensor that lets our system make decisions. It's time. Let's put it all together and create our finished alarm.
And here it is, the final evolution of our circuit. We've added one last crucial component, a buzzer. Because, let's be honest, a visual alarm is good, but an audible alarm, that is impossible to ignore. We're giving our system a voice to shout when something goes wrong.
And how hard is it to add sound? It's this one simple line of code. That's it. This command just tells the brain, hey, when that error condition happens, send an electrical signal to the buzzer pin and make a sound at a frequency of 440 Hz. Just like that, code becomes sound. So let's just take a quick look back at our journey. We started by just controlling an output. Then we learned to automate a sequence. After that, we gave our system senses to read an input and make its own decisions. And finally, we combined everything to create a complete audio-visual alert. Each step built directly on the one that came before it.
So why does this little project matter so much? It's because this isn't really just about lights and buzzers. It's about understanding a fundamental concept that, frankly, powers our entire modern world. It all comes down to this single, really powerful idea. The goal of this entire process, whether you're building a simple alarm or a crazy complex robot, is to connect abstract instructions, our code, to decision-making logic, and then have that logic create a real, tangible effect out in the physical world.
And here's the most important part. That phone that's in your pocket, the smart thermostat on your wall, even a satellite orbiting the Earth right now, they all work on these exact same principles. They take in data through sensors, they process it using logic, and then they produce an output. We just built a miniature version of that very same loop.
So we started with a single light, and we ended up with a smart system. We've proved that from the simplest building blocks, you can create something that reacts, that decides, and that alerts. We built an alarm. So the only real question left is, what would you build next?